Hi, so for today we will look into free falling bodies. Okay, so for a free falling body, you should be able to describe that the body will experience acceleration which will be equivalent to gravitational acceleration. Okay, and then you should be able to solve some problem related to this. Okay, so when we have a free falling body, we can define as a vertical motion of a body at constant acceleration under gravitational field without air resistance. Okay, and then in the earth gravitational field the acceleration will be constant. Okay, also known as the acceleration due to gravity, or we call it as free fall acceleration, or also gravitational acceleration, where the value will be equivalent to 9.81 meter per second square. The direction will be always toward the center of the earth, which will be downward direction. Okay, and then the one important thing is that involved in all our calculation, we do one assumption, which will be that we ignore the air resistance. Okay, for now, for the sign convention, whenever an object moving upward, you will have a positive direction. Moving downward, we will have a negative direction. Okay, but when we throw an object upward, okay, it will experience deceleration. Therefore, the value of g will be equivalent to negative. But when an object falling downward, okay, it will experience acceleration but in negative direction. Therefore, also the value of a will be equivalent to negative g. So previously we have equation of linear motion. So what you can do is that you can replace the value of a with negative g and then rewrite the equation. Okay. So we will end up with this final table, okay, where what we do is that we modify a, replace it with g. Okay, an example of free falling body motion. Okay, so for example over here we take a ball which is thrown vertically upward. Okay, where we will have initial velocity. So as the ball moving upward, it will experience deceleration where the velocity will decrease with time, and at the maximum height, okay, the ball will stop and it will change direction. Okay, and then it will accelerate downward. Okay, where the h will be the maximum height. So maximum height will be obtained when the velocity is equivalent to 0. So when an object moving upward, this will be your initial velocity over here. Okay, this will be your initial velocity, and over here you will have final velocity which will be equivalent to 0. But when the object changes direction, so over here will be your initial and this will be your final. So for this point where you have the maximum height, your initial and final will be equal, which will be equivalent to 0. Okay, so for the motion, we can also put it in a graph. Okay, so when object moves upward, it will decelerate. So that means velocity decrease with time in positive direction. And then it reaches maximum height, velocity becomes 0 and it changes direction. Okay, changes direction and the velocity increase with time. So this graph we also put it in v versus time graph, okay, where the velocity decrease for the first half and then velocity increase but in the opposite direction. If you plot the a versus t graph, if you calculate the gradient, you will get a constant gradient which will be equivalent to negative g. Okay, so from here we know the final velocity becomes 0. Okay, and then if we replace the v value 0 into this equation, rearrange, we can determine the value of t, time taken. Okay, and then another derivation is that we can determine the maximum height. Okay, so by using this equation, or another one, this one equation, okay, where we replace s with h, okay, which will be the maximum height, Okay, replace in final velocity becomes 0, and then rearrange, maximum height will be equivalent to u square over 2g. Okay, so for the initial equation, we also rewrite in terms of y component. Okay, where free fall motion involves vertical component, so therefore you can rewrite as a y component. Okay, so for y component, what you do is that you just add in a subscript of y. They want to determine the direction. Okay, for example 5, you have a ball thrown up from the top of a building. Okay, then given an initial velocity of 10 meters per second straight upward, the building is 30 meters high and the ball just misses the edge of the roof on its way down as shown in figure 2.7. So this is a figure. So you have ball thrown over here, initial velocity. So the motion will be, it will moving upward until it reaches a maximum point B, and then change direction. Okay, point C, which will be equivalent to point A, and then it further travels down to point D, which will be 30 meters below the building. Okay, so for A, they wanted to calculate the maximum height of the stone from point A, and then B, time taken from A to C, and then C, the time taken from point A to D, and then D will be the velocity of the stone when it reaches point D. Okay, for solution A, okay, when it reaches maximum height, the final velocity becomes 0, and then from the question we know that the initial velocity is equivalent to 10. Okay, so replace in equation. Okay, final answer we will end up with 5.1 meter. So this will be the maximum height. Okay, so that means the distance travel from A to point B. And then from point A to point C, the displacement will become 0. That means A to B travel in positive direction 5.1, and then B to C travel in negative direction 5.1. So that means the total displacement will be 0. Okay. So therefore, applying in this equation, okay, total displacement becomes 0. Initial is given as 10. Okay, G will be constant. We want to determine the value of T. So solving this, we will end up 2.03 second. Okay, and then from point to D, A to D. So that means it travel A to B, and then back to C, and then C to D. So the total displacement will be negative 30 from point A to point D. Okay, therefore replace in over here, initial given. Okay, total displacement will be negative 30, and then G will be constant. So we solve the value to determine the final answer T. So for this part over here, you can use equation solver at the calculator lah. So what you can do is that you can rearrange in terms of ax square plus bx plus c. So value A will be equivalent to 4.91, B will be equivalent to 10, and C will be equivalent to negative 30. If you use equation solver, then you will end up with final answer. You will get 3.69 or negative 1.66. So for the value of time, we will always have a positive value. So that means you can ignore the negative value lah. Okay, because time don't exist in a negative domain. Okay, so for the next one, time taken from A to D is 3.69. Okay, so what we can do is that we can replace in the equation to determine the final velocity over here. Okay, which will be at point D. Okay, now what we can do is that we can also use the displacement in Y. So replace in over here to determine the final velocity. Okay, which will end up with the same value also. Okay. So therefore, the force velocity at point D will be negative 22 meter per second. Okay, thank you. That's all for today. Thanks for listening. Have a nice day.